Good morning, at-home learners. It is Friday. So let's take a look at what we are getting into today as we are learning at home. So first for today, we're going to finish up the last section of our chapter on the universe, which would be section 4. There's a PowerPoint presentation and guided notes. I have a little brain pop for you to watch as well. I've got a Jeopardy game that you'll unfortunately have to play by yourself, or if you want to call some of your friends, you can sign up and play together, and one of you can keep score. There is a little Galactic Neighbors worksheet. It's optional, but it has to do with the spectroscope if that's something you're interested in. And then for homework tonight, you have a section 4 form. Remember that it auto grades it, just so that you get the immediate feedback of knowing what answers you got. But remember, we look at it, so if you miss something or it says you missed something, even though you got it correct, we'll take a look at that. Excuse me. So yesterday you did the Doppler shift lab. We'll go over that, and you had your chapter review form. So hopefully you turned those in on time. And yeah, so let's go ahead and go over that Doppler shift lab. So you got to listen to these cool little songs and some of the videos, and hopefully you got to see me swinging around my phone. And this sort of sets up the procedure for you. And again, the loud, annoying, buzzing sound. So what did you find? So if you were the one spinning the device around your head, so you were in the center and it was going around, the sound should have stayed the same because the distance from you and the device shouldn't move. It's the same distance, even though the location is different. The distance from you to the annoying buzzing sound stays the same, so the sound stays the same. However, if you were another person standing outside of that little system, as it approaches you, it's going to get loud. And right as it's at you or closest to you is when it's going to be the loudest. And then as it passes you, the sound is going to be less. And as it goes away, it's going to be even less louder. Excuse me. All right, and then again, this gives you a little further explanation of why that happens and kind of gives you the why of it all. And then we've got these questions down here. So does the person swinging the Doppler device hear the Doppler shift? And no, again, because the distance doesn't change as you're spinning it overhead, because the sound waves aren't compressing or expanding towards your ears as the device is not moving any closer or farther away from you. And can the red shift, blue shift technique be used for objects other than stars? Yeah, anything that has like electromagnetic waves, like sound and light waves, you can use it. So can you tell which way an emergency vehicle is traveling by the pitch of the sirens? Yes, it's definitely getting closer to you as the sound or the pitch increases, as it gets louder. And what has the Doppler shift told astronomers about the expansion of the universe? It's telling us that the universe is expanding away from us in all directions. All right, so then let's go ahead. You can get out your guided notes for section 4, and you can kind of follow along as I read over these. So, and you also want to open up, or you can follow along with me, the section 4 cosmology. And so I laugh. Sometimes I think students confuse cosmetology with cosmology. Cosmetology is where people go to study to learn how to do hair and makeup and sometimes nails, where cosmology is the study of the cosmos and how the universe formed. So here are our essential questions. What is the most accepted theory used to explain the origins of the universe? What evidence is used to support an expanding universe? What is dark matter? And how does dark energy affect the expansion of the universe? Here's our vocabulary words, the ones that we'll review, and the new terms. So it says the expanding universe. So the study of the universe, how it began, how it evolves, and what it's made up is cosmology. And one of the things that's involved with it is the Big Bang. And perhaps you've seen the TV sitcom, The Big Bang Theory. Again, a bunch of scientists basically trying to figure out the study of their own universe, somewhat like the beginning of our own. So remember, the Big Bang is a theory, which is just an explanation, trying to explain how we think the universe formed. And so what this one says is that all matter and energy in the universe were compressed into a single point, which began to expand outward. And that's what's called the Big Bang Theory. That single point they call singularity. And it states that the universe started with this Big Bang or explosion and has been expanding ever since. The silly thing is, even though it's called the Big Bang, if you recall, there is no sound in space because there's no matter, like there's no gas or air, any matter other than, the planets, for the sound to travel through. So it wasn't a Big Bang like we would imagine it to be, but it is an explosion of matter into space, and it's rapidly expanding that space. So it's what's making all of that happen, I guess, because it's the very beginning. There is evidence, so it's not just like they made this guess. So there is cosmic microwave background radiation, and like a microwave, like you make popcorn in, it's the same sort of waves that help that popcorn pop, but we can see sort of traces of it left in the in the universe. And so this radiation is residual, and they were able to tell and find it when they had a special probe that they sent up into space. They also sort of concluded that they believe the universe began 13.7 billion years ago, which is also the same time as when the galaxies started to form. So just like you did in your lab, the Big Bang is evidence that, or evidence for the Big Bang is through the Doppler effect. So you can look at that little airplane down below, and you can see how the sound waves are compressed up front and spread out towards the back. So the Doppler shift can occur with light as well as with sound. So if a star approaches Earth, its wavelengths of light are compressed, causing a blue shift. If a star moves away, its wavelengths are stretched out, causing a red shift. And so here you can see this is the source where it started. If it's moving, in this case to the left, you can see on this side, it is the sound waves or the light waves are compressing. So what is our universe made up of? Well, it's either made up of visible or detectable mass, solids, liquids, gases, plasmas, and this is just regular matter that we're going to be learning more about. It appears to make up a very small part of the known universe. And remember, there's many parts of the universe that we don't even know about. But there is also a part called dark matter, which is this invisible form of matter that it doesn't emit any detectable electromagnetic radiation. So observations show that there's about 5 to 6 times as much dark matter in the universe as regular matter. So this, what is it made up of? Well, it's made up of dark energy. So data indicates that the expansion of the universe is accelerating, and it's hard to explain this acceleration. But the dark energy is an invisible form of energy that causes this repulsive force in the universe to accelerate faster. So this is a really short section. Down here is the Jeopardy game. So if you go, excuse me, into that, you can take a look at that. All right, so after we're done with the brain pop, you want to go back to this. I'll click on it now so you can kind of see how you need to set it up. I'm not going to go through and play it with you. You can just play it as flashcards. You can play it as a memory game. If you can call up some of your friends and play it, it's a great way to review. You'll just, put in play now. And I think you enter how many teams. If it's just you, just enter 1. And you could even play in buzzer mode. It lets other teams, if they're playing from a phone or something, buzz in. If not, just press no. And you can pick I'm going to choose this one, your group, and, figure out how to play. And you can, it goes through the steps of doing that. So just check that out, play through it. There's lots of quiz questions on there, so you'll want to know the answers. I also have this vocabulary sheet for you. I'll put it up here if you are able to take a picture of it. These are some of the possible answers. Some of them are not answers at all, but some of them are answers to the question. So if you need that, you can definitely look at that. All right, so let me show you this nifty little video, and then you can get on your way.
Dear Tim and Moby, how did the universe get here? Thanks, Iris. Any ideas, Moby? Well, no one really knows what was happening before the universe came into being, and almost every religion has its own set of beliefs about creation. But most astronomers agree that something called the Big Bang Theory explains what happened at the very beginning of the universe. According to the Big Bang Theory, the universe started up around 14 billion years ago. Back then, all the stuff in the universe was packed together in one dense point called a singularity. It's hard to imagine, but that little ball contained all the elements that would make up the universe as we know it. Now, no one is really sure why, but this singularity exploded, sending not just matter, but also space and time flying in all directions. That cosmic explosion is what we call the Big Bang. It was real hot at first, about 10,000 million degrees. After things cooled down a bit, the first stars and galaxies began to form. All the matter and energy in the universe continued to expand from that initial burst, and it's still expanding to this day. The Big Bang Theory explains why. Oh, okay, all right. Imagine you decide to bake some raisin bread. I don't care if you don't like raisin bread. It's just an example. Anyway, when you put the raisin bread in the oven, the raisins are pretty close together. As the bread cooks, it expands, and the raisins get farther and farther apart. There's really no center to it. Everything's just getting farther and farther away from everything else. You can think of the planets and stars and galaxies in the universe as raisins in a really big loaf of raisin bread that is constantly expanding. But no, it's not going to get burnt. It's just an example. Like other scientific theories, the Big Bang Theory is more than just a guess. In science, a theory is an interpretation of how some process works based on lots of hard evidence. Of course, the Big Bang wasn't always so widely accepted. It was first proposed in 1927 by a Belgian priest and astronomer named Georges Lemaitre, who proposed that the universe started in a giant explosion. There have been other theories about how the universe began, too. One was called the steady state model, and it said that there didn't necessarily have to be a beginning to the universe. Matter just sort of appeared. But a few years after Lemaitre came out with his theory, American astronomer Edwin Hubble discovered major evidence supporting the Big Bang. His observations suggested that not only is everything in the universe moving away from everything else, but that all matter has taken the same amount of time to get to where it is today, while starting off from a single position. Later in the 1960s, and especially in the 1990s, several radio telescopes provided even more concrete proof that the Big Bang Theory is correct. In fact, one telescope was able to look so far into the distant universe that it actually found leftovers of the radiation given off by the Big Bang. No, it's awesome. Isn't it amazing how scientists are all discovering new things about this universe of ours? I mean, you never know when...
So silly. All right. And so when you're done with that, you can also, remember, don't forget to do the section 4. But if you go to Virtual Monday, on there was the Bitmoji for this section. And so like if you click on the bat, or the ghost, or the pumpkin, the cauldron, the skull, the spiders, the chair, there are little things that review this chapter. And so that might be a really good thing for you to review, excuse me, before the test on Monday. Other than that, if you have any questions, please don't hesitate to email me by the end of the day, and we'll get it all taken care of. Thanks so much.